Our task now is to talk a little bit about how some of the most amazing technology is going to influence the way we make decisions in healthcare and human services, and even in the justice world as we move forward to embrace this new technological wave that's really upon us. And it is a change that affects every one of you, whether you've thought through this yet or not. It's going to impact your work and your life. So I want to, at my age, I'm comfortable telling stories more than trying to lecture you about technology. So I'm going to tell you a little bit of a story about the trends that have come together and are converging to influence the delivery of health care and human services in our nation and in the world. 60 years ago, there was a young guy named Thomas J. Watson, Jr., whose father died. And at that point, he was forced to take over a company his father had created. That was Thomas J. Watson, Sr. And his father had brought together several companies and made this new company called the International Business Machines Company, better known for their ability to make punch card machines. Most of you are too young to know what a punch card is, but they're little cards with holes in them that allowed you to represent zeros and ones. And this company was a good manufacturing company and made a lot of those things. And then as Watson Sr. died and Jr. came along to say what to do with this company, he realized the company was in a little bit of a problem relative to its market, because there weren't a lot of market, wasn't a big market for these anymore, and they knew they had to do something innovative. And he had these guys working in a research lab in Armonk, New York. Now, I don't think most of you have ever been to Armonk, New York, but it's a nice little area in the countryside where research labs can really take off, and people love to work there. And they had these guys that figured out that you could make these devices out of sand that would hold a 0 or a 1 if you put the right electricity on them. They called them transistors. And they figured out you could put a lot of them on a plastic board and make them do the same kinds of things they were doing with punch cards. And Thomas J. Watson Jr. said this, you know, we ought to make machines that take advantage of this. And so there's a guy named Eugene Kleiner who was in that lab, and he actually ended up moving to California in Palo Alto, and he teamed up with a guy named Gordon Moore, and they made this new company, little company in Southern California called Intel. And they started to manufacture these things, and IBM then said, well, this is good. And these machines were really good at counting things. They were good at adding and subtracting. Multiplying and dividing was a little harder, but they eventually figured that out. And so they proceeded to make machines for 50 years. It started now 60 years ago, almost today. For 50 years, they made machines that counted things. They counted faster and bigger and better, and also smaller when the IBM PC came along. And that was the whole lifeblood of this growing, massive company that grew to the point of hundreds of thousands of people. At the same time, what was going on this now 60 years ago, there was a bunch of researchers and scientists that said, you know, if we could only figure out how to use technology to emulate the process our brain uses to process things, and we could create this thing called artificial intelligence to expand our limited brain power and really build some neat things. So they started down that track, and they kind of settled on building robots as the first way to get started in artificial intelligence, and they kind of miserably failed. Over the years, they couldn't really do what they wanted to do. So our brain is just too complex. We can't mirror it in technology, and it's the whole movement of artificial intelligence just kind of dragged on and on and on. And this went on for a long time, and people finally realized that it wasn't just emulating our brains that was needed, it was augmenting our human experience using technology. And so the movement in artificial intelligence was more towards the idea of generating knowledge and sharing knowledge based on the use of more sophisticated algorithms and technology. And that went on for about 50 years. So here you have this little company called IBM making better machines and bigger machines and smaller machines and lots of these machines, thousands of them. Thomas J. Watson initially said, I think there's a market for maybe 5 computers worldwide. It's a true story. He made that statement early on in that, but that was because they had spent a lot of money and energy trying to build one computer for the Census Bureau. But anyway, they built a few more than that. And then what's happened in the last decade is that these two trends kind of came together. IBM, and I'm not sure exactly when this happened. Martin may be able to pin this down, but in the last decade, the IBM engineers and scientists came to an incredible, revolutionary finding about computers. They said, you know, it's good that we figured out how to count things, and that's fine, and we'll still use computers to do that. But we're here to tell you there's a new purpose for computers. It's no longer about accounting. It's no longer about counting money. It's no longer about accounting things. The purpose of computers in the future of IBM is to provide insight. And they did this because at the same time, these artificial intelligence people started realizing that they had to figure out ways to share knowledge and find patterns that were invisible to the naked eye, so to speak, and that were contained in data. And we had companies like Google and eBay and Amazon who invented these new concepts of databases that had nothing to do with the structured query language that IBM had settled on, and Oracle and many others. They invented these unstructured database concepts that allowed us to look at structured data and unstructured data and make sense of it. And that, coupled with the work that IBM had done to build bigger, better, faster machines, all of a sudden came together. So it became possible to invent this new mantra that computers are here to provide insight. Now, none of this would have happened, except also in the last decade, a whole slew of universities began to realize that this was a change in our whole paradigm of how we use computing. So in the last maybe 4 or 5 years, 29 universities at last count in this country have created graduate degrees in data science. Never did we even have a degree like that prior to a decade ago. We also have seen new programs in knowledge management, knowledge engineering, to take the artificial intelligence world further to the point where George Washington University now offers a PhD program in knowledge management. It's graduated some couple hundred PhDs in knowledge management. And the combination of these things, of having the resources with academic programs to teach this, and by the way, if you're thinking of a new career, now's the time to jump into it, because the demand for data sciences is unbelievable in government and industry. But with that arrival of university programs, academic discipline of knowledge management and data science, IBM's work towards understanding that computers have only to do with providing us insight, and the maturity of the notions of how to deal with massive amounts of data. And we're not talking about the few thousand bytes of data that most systems take advantage of. We're talking about not gigabytes anymore, not even petabytes, but zettabytes. You don't even know what that is, do you? Because I didn't know. I had to look it up. There's too many zeros for the human mind to comprehend. But that's the level of data manipulation we're capable of doing. So how does this affect you, and how does this affect all of us in the practical world? We're going to hear from a couple of real-world examples of how this is really going to change the way we think about health care, about human services, and about the interaction of health care, human services, and justice, and solving the practical problems that these tools can now enable us to do. There's 2 things that I would put in your head that are going to change from this day forward. If you haven't already thought about it, you're going to think about this and you're going to agree with it and see it in your own lives. One is that we're going to take advantage of the technological capability of finding insights into data, large amounts of data that we've never had before, to find those things that go beyond what is intuitively obvious. The second principle that's going to affect everything you do is that we're no longer going to accept the time constraints of generating insights into data or looking at data. And part of that is one of the reasons we're here at this conference, because once you put this data out and available to the public and put it on the web so they can see it, they don't see any reason why it can't be in real time. What do you mean it takes 2 years to get the data that you need to show me what's going on in the healthcare field? You know, the president relies on a national intelligence estimate that all the 16 major intelligence agencies in the country take 1.5 years to generate and another 6 months to vet. So by the time the president sees it, it's 2 years old. We won't tolerate that anymore. The public won't, and agencies won't. So that we're going to insist on real-time results and real-time data, and we're not going to accept the delays in getting insights that this technology can offer. So with that as background, we're going to introduce you to two speakers who are going to talk about the real-world possible applications of machine learning, cognitive computing, as it's called, and its application in the cancer field. So our first speaker is Martin Duggan, who is the Director of Strategy and Marketing for IBM's Watson Health program, named, interestingly, after Thomas J. Watson, Jr., who started all this mess and brought us along to take advantage of this technology. So let me turn this over to Martin.
Afternoon, everyone. A history lesson for some of us in the room. So I'm going to talk a little bit about some of the stuff that we're doing and bring some of the applicability to some of the other conversations that have been going through today. We're going to do a bit of a switch around on the agenda, on the podium. I'm going to talk for a little while. Then Steve's going to come up and talk about one of the examples that we've been doing with the Cancer Institute here in California. And then I'll come back on and finish off a little bit with another example. Earlier on this morning, I wrote down one of the, well, I can't remember who presented it, but talked about the empowered patient and the changes that are coming through in that type of thinking. I think it's more than just the empowered patient, it's actually the empowered individual. Someone else was talking this morning about the transport scenario. I'm the guy who uses Google Maps to go across 4 different public transport mechanisms in London because it's quicker to go that way than it is to drive, and I now actually feel confident about actually doing it, that actually I can actually make the linkages between the different transport systems. But it's more than just the empowered individual. And going back to your point, Paul, about the information becoming real time, it's very true. I don't want to wait 2 years to find out my train's late, and there's another way to go to that will get me there just as fast, right? But Karen, I think, talked earlier on about the social determinants of health, and what I want to draw in the presentation I'm going to give now is some linkages between those social determinants and the reality what we have to do to address some of those situations as a human services organisations in one form or another. And I'm just looking for the clicker. So we're going to talk about cognitive social programs. Paul did a great thing about talking about Watson. How many people remember the introduction of Watson and Jeopardy and this thing? Reasonable number of people. Well, it's more than just Watson now. This morning in the Wall Street Journal, I read about what happened over the weekend or during the last week with Google's work on the Go game. Yeah, that's quite transformative. Just in a couple of years, the whole intelligence area moving, leaps and bounds. I also read that the most profound technology change that the Wall Street Journal was talking about was augmented reality. A lot of the work that Microsoft, for instance, has been doing around visors and things and all the different things there. So there's a whole load of these different types of machine learning type technologies that we think are actually going to make quite a profound difference to life. But what Watson did was really apply the thinking and the logic element around it. And that's really what I want to talk about today, is where we're going with this whole approach to cognitive. And, fundamentally, it's about taking the ecosystem of what is turning data into information and then applying cognitive to actually generate knowledge. And that may not seem very obvious at this moment in time, but as I go through this presentation, hopefully that will become very more obvious to you, that the fundamental difference that cognitive applies is actually creating knowledge. And there are some very different things we have to do as organizations when we start thinking about knowledge rather than information. And at the end of this presentation, I'll talk about what we're talking all around the world, a call to action to organizations like yourselves to play a different role in this knowledge ecosystem, that we can actually make a profound difference to people's lives. Fundamentally, humans excel at things like common sense, dilemmas, morals, compassion, imagination, dreaming, abstraction, and generalization. And what cognitive systems excel at are the ones on the bottom: the natural language processing, pattern identification, locating knowledge, machine learning, eliminating bias, and hopefully endless capacity. And I think that's an important thing to draw out, because what I'm not going to say to you today, and we have a little bit of fun at the end of the presentation, it's not about the machines taking over. This is not about Terminator and Skynet and all of that type of thing. This is about helping make better decisions, helping people make better decisions. And that's fundamentally what this is all about. So what Watson does as a cognitive system, first of all, it can read and understand data, and not just normal structured data, but unstructured data as well, but on a massive scale, millions of documents at a time. Right? It can reason, and you'll see some of this as we go through. It searches and analyzes the data, really trying to return evidence-based recommendations. That's a key word there, evidence-based. And we'll come back to that a little later in the presentation. And then finally, the fundamental bit is that it learns. As you see that it presents options to you and it sees the decisions that you make, it actually learns that and actually feeds that back into the learning system. So we set up a new division in IBM, really focusing on health and human services, really focusing on this whole application of technology. Something that's the first time in IBM, I think in 15 years, we've created a new division. It's called Watson Health. It's health and human services. And we've been spending a lot of time over the last just over a year now focusing on how can we really, truly fundamentally change some of these dimensions. You may have heard some of the partnerships. You may have heard some of the work we've been doing, things like the Boston Children's Hospital, right, looking at rare diseases, rare cancers for children. Watson for Oncology with Boston Sloan Kettering, looking at how do you actually find the best treatment pathways for cancer patients? How can you actually take a learning from the best physicians that exist on the planet and actually make that available to everybody? We talk about democratizing expertise, and that's fundamentally what we're trying to do here, is find the best practices, the best examples of what you can do and make them available to everyone. So we've done a lot of work in the health area. We're now moving into the human services area as well. And to pick on, sort of going back to Karen's comments about the different types of data, and I loved, I can't see where she is, but I loved the pictures you put up there that you built up on the different social determinants of health, because I have a very similar chart that last time I presented I actually had as a moving one, but unfortunately I spoke too long while the person was going. What this really is pulling out is the huge amounts and volumes of data that now exist. How many people, you can't see mine, but this is not a Fitbit, this is a Jawbone. How many people have one of these things on their arm? Yeah, a reasonable amount. 10 years ago, I used to ask how many people have a cell phone. I got about the same number of people. Then I asked the question, or actually a colleague of mine asked the question at one of Stewards Change Symposiums, how many people have given them to their caseworkers, and there was nobody put their hand up, right? Nowadays, hopefully most of your organizations have got something like that sort of technology out with your caseworkers. The point is the volume and velocity of data is exponentially increasing every year. When we look at the social determinants and the things that are now available in terms of what we can actually look at, what we can measure, what we can monitor, if we have permission, and I'll come back to privacy a bit later as well, has radically increased. And there are organizations out there in the world that are actually asking people if they're willing to share this data. And guess what? The answer is yes. In almost every case where organizations have actually gone out and actually asked, are you willing to make this data available for the right purposes? The answer is yes, the people are. So it changes the whole dimension about what we do and how we can do it. So what we're doing is looking at the whole social programs area, the human services area. And this is just an example of the type of processes. You'll have your own version of this in terms of what you do. And what we're doing is we're looking at how cognitive can be applied at each step of the process. It's not just a small example here or there. It's fundamentally about changing the whole process at every stage of the process in terms of how cognitive learning can actually apply there. Now, I'm going to go through the next few slides relatively fast because there's a lot of them. So you'll have them as available to pick up at a later stage in terms of looking at. But what we've done is we've looked at the use cases that we believe cognitive computing can apply at each step along this process. And these are not limited by any means, but there are a whole load of them. We're going to talk about a couple of them in a bit more detail. But what you see here is the... Do we have a... Oh dear, that wasn't a good idea. What you see is in these little icons here, these are actually what are called the Watson APIs. So these are the APIs that you can program to, that you can access as developers anywhere around the world. They're open APIs that are available for anyone to build into their systems to look at. And you can actually go and on the websites, download these or access these and develop to them. And what we're looking at is new ways of capturing information. How caseworkers can leverage Watson for guided 10 minutes, guided interface and reducing manual entry. One of the things we did last year is we ran a competition. The University of Texas won an award for $100,000, a couple of students there, and about how they could apply Watson to 211. To actually allow people to just put free text into there and actually find the best services that are available in the local community. Just one example of the type of things we're doing. When we look at accessing, there's a whole lot of different things you can do there. And what I'm going to do now is I'm going to ask Steve to talk about one example of access, about where Watson does automatic verification and matching of screening of information in a high volume way. So, Steve. Just
on the far right. Okay. Oops. Hi, I'm Steve Fuchslin with the California Cancer Registry, and I joined the Cancer Registry about 15 years ago. The goal at that time was to move it from 19th century paper-based practices to 20th century electronic business practices. And I'm here today to talk about how it is that we can move the Cancer Registry to 21st best practices and technologies. So we're now electronic. We're asking this organization, how can we move forward to move into the 21st century? And that's what this opportunity, this proof of concept is about. A little bit of information first about the Cancer Registry. It's the largest data warehouse of cancer information in the United States. It contains over 6.5 million cancer reports, 5.5 million tumors, and 4.5 million patients. It's not a database, it's a data warehouse. That data has all been quality controlled, linked to the patient, linked to the tumor, and then consolidated for research purposes at great expense. Along with this, we collect tens of millions of other records, which we also link to each patient and tumor. Now the purpose, I'll go through this quick. The purpose of all this is to save lives, but what we want to get to is how that's going to happen with 21st century technology. But first I have to explain to you the current process, because this is what we want to move away from. We want to move away from this to the 21st century. Here's the crazy work that we have to do to create cancer data for research purposes. This is a SIPOC diagram, SIPOC, suppliers, inputs, processes, outputs, and customers. On the left are the suppliers of data, and you'll see hundreds of thousands and millions of records that are sent to us, all of which are manually or electronically linked to patients and tumors, and often and much of that work is still manual. About 80% of the work is electronic, and about another 20% of the work is still paper-based and manual. there are some missed opportunities in this model that we'll talk about where we want to move towards, and which are very much in alignment with what the purposes of this meeting is, of what this conference is today. The first would be interoperability. If you look at the chart, the SciPlot diagram, the data is moving left to right. And it takes about 2 to 3 years for that data to move its way to the National Cancer Institute and to the Centers of Disease, CDC, where then 3 or 4 or 5 years later, there's research done on that, right? Well, and the operability is basically flowing one way, left to right. So we're here today to ask you, how could we change the interoperability of this for it to be bidirectional, for the public to access it, for physicians to access it, for it to somehow be of immediate use to you as the patient, not a 3, 4, 5 year blip later on a trend chart. Rural physicians ask me, Steve, how can I follow my patient? I've had a patient, they go somewhere, I don't know whatever happens to them, I don't know if they'll ever die. How is it I can follow my patient? And if you're a patient, is there something here where you would be able to access this data? So part of this is we're asking you, how can we move into the 21st century world of interoperability? Second would be content. The content of this data, well, we're going to show you today in our proof of concept where there's hidden value in this data that's not being used right now. How can you all help us to unlock that hidden value in this data, but also then work with the suppliers of data and the software vendors, the large software organizations, so that they could be collecting data in a way then that would be of greater value to us in the real time, but also for research and public purposes historically. The third would be decision support processes. That is, it's what we're talking about here. There is no decision support built on top of all of this data. Well, why not? Help us again move into the 21st century with that. And the fourth is extending it into real-time data versus this historical 2-3 year look, and also extend it into data sources that are currently not part of it, and that would be the patient experience, et cetera, hospice, home care, things like that. Now, on the bottom left, you'll see this thing called Eureka Case Finding, Unreported Cancer Case Identification and Acquisition, and that's sort of key to the story I'm going to tell you. So we're collecting about 500,000 electronic path reports, and we're collecting about another 500,000 paper path reports. And we actually look at these path reports a year or two later when we do not have a cancer case. And this is the great expense that we have at the Cancer Registry in collecting every single cancer case. As a population-based registry, we're collecting every single cancer case that is expected in California, 100%. We're not just collecting those that fall in our laps, we collect every single one so that you can do our research based on population research. To do that, we have to go discover those cancer cases that don't fall into our lap. And where do we find those? Well, we look at every single death certificate. So we have someone died of cancer, but we don't have a cancer case. So now we have to go follow back to that physician, to that reporting source to get the information about that cancer case. Another source of that is pathology reporting. So this is the great lost opportunity here. So we're collecting all these path reports, but we actually don't use them for any purpose other than a year or two later to discover unreported cancer cases. Well, that's relevant to the story that I'm about to tell you. So one day, last year, a year ago, this paper came across my office, and on it, I thought, wow, the conclusion, which was at the very, very top of it, was that given this condition, people were dying. And my first thought was, we're collecting all these path reports. Why can't Jeopardy, Watson, that kicked Ken Jennings' booty, why can't we have that look at this data and see if it can discover the same conditions as this use case? So basically, here we're collecting all these path reports to discover in a very expensive way cancer cases aren't reported to us. That data is sitting there, right there. How can we repurpose that data for modern 21st technology uses? I'm challenging this room. I'm begging you all to help us. We don't need to wait any longer. There are opportunities right in front of our face. Let's go do something about it. Well, that was my question. Could Watson discover the use case conditions in near real time, alert both the physician treating, diagnosing, but gee, this is even a greater question. Now that we have this information, should we be alerting the patient? I won't get sidetracked on that today. But that's a really important question. We can talk all you want about open data, but here, this is a real ethical, legal, moral, whatever type of question, right? Would you want to know about this condition that potentially you could die of? Would you want to be alerted, or do you just trust that somehow that'll work its way back to you or not? And right now, we're not alerting anyone. So yes, could Watson do this? Well, how could it do it? Well, it was actually very easy. Last November, we just installed a server, took a couple of hours. We put in a web-based service, RESTful, that took another couple of days. So within 2 days, we've hooked up to Watson services. We ran 1,000 bladder cancer cases through it. Hey, guess what we discovered? What we discovered, and when the data came back to me just about a month ago, end of January, was that sure enough, green means that the use case conditions are not present in the path report. Red means the use case conditions were discovered in the path report. And so here is evidence right here of how our data could be used to save lives. And we're asking you, well, what are we going to do about it? Are we going to sit here and talk possibilities and hypotheticals, or are we going to move to action with some of these things? And so, again, I'm going to challenge this organization. And we talked about innovation this morning. You know, how do we move from these sort of real-life possibilities to action, and what's it going to take for us to do that? So I'll go back to how we started this conversation. Our current model, we want to blow that up. We're glad that we're no longer 19th century paper. We're like, you know, barely internet, 20th century. There isn't any reason why we couldn't be 21st century technology if the folks in this room wanted to do something about that. We're talking about using the cancer data, which is the most robust data of any disease really in the United States, and let's use it to be bidirectional. I'm challenging you. How could you use that data differently? Let's look at the content. Free-form text is bad. I'm glad Watson can read this. What else could we do to be working with the providers of that data and the software vendors to create structured, standardized, aggregated data, things that we could do something with, something that the patient, that could serve the patient in an immediate need versus this historical 3-4 year look later on for research. If you have cancer, I can tell you right now, that you don't want to be a blip on the trend chart, on a historical 4-year chart. You want to know that minute, what new treatment came out, what new eligibility trial, what new drug came out that morning, what new paper was written regarding my cancer that might save my life. You want to know in real time, that morning, that day, and for your entire experience, what is happening that could help you save your life. You are not interested in being a blip on a 4-year surveillance trend chart of something going up or something going down. Decision support systems, we have now proven that this 21st technology has viable use for our data, and what else could we do with it? We could probably duplicate this thing very easily in a few months, a dozen times, but if you had a whole team working on it, I bet we could come up with 100 of these things. They could be saving lives next year 100 times over, and in 5 years, you have the whole team working on this, you'd be saving thousands of lives in California. Faster, cheaper, better patient outcomes, savings of lives. You'd be doing it cheaper. You'd be having less malpractice lawsuits, on and on and on. This is all possible. How do we do it? And we want to move to real time. We're not interested in what Paul was talking about. Who cares about 2-3 years? The public wants real time. I have this question I ask, and then I'll end. I'll be finished. If your child or a family member had cancer on your block, and 10 children on your block had cancer, how long do you think it would be before the public, the county health department knew that, the State Department knew that, or the Cancer Registry knew that? I have asked 50 people that question. If 10 people on your block had cancer, what would be your expectation in the year 2016 for something being done about that? And there has never been a person that has said to me, Steve, I think it's going to take you 3 years to figure that data out, or 2 years, or 1 year. No one has ever said more than 3 months. Most people say, I would expect the public health department and the state health department to know something about those 10 cancers within a week, within a month for sure. No one ever says 2 years from now. And if we were moving to real-time data, then that data could be of use to the patient in real time as well. If we had the pathology data coming to us in real time, we could be alerting you of a clinical trial possibility. We could be putting decision support systems on all this data, potentially saving your lives at a lower cost. So I'm fired up, you guys know this. I will now move back to Martin and Paul, but we are very much want to know, we're announcing the Cancer Registry wants to move in the 21st century. Please help us do that. And the last thing is, if we can do this for cancer, if we can collect what we're saying real-time data across the cancer care continuum, and we'd like to extend that into the patient experience as well, then if we can do it for cancer, then we can do it for every other disease, and you could do it cheaper, faster, better. If this can be the model for cancer, you could then do it for every disease. You just repeat through it. You iterate through it for every disease. Why aren't we doing that? This is the 21st century. Okay, thank you.
Passionate. So I want to give one more quick example of what we're actually doing in terms of productizing some of these types of features, and going to talk down in terms of what's in helping make more informed and optimized decisions. And this is something that all of you do every day, selecting providers for care with your organizations you have contracts with. And what we've just done is looking at how, from the case management system, that when you're in the process of going through selecting a provider, how can you make that a better set of decisions? You know, typically, if you've got hundreds of providers that you've got to choose from, case workers will typically choose the ones that they're used to using. Right? So, how do you make that more dynamic? So, what we've done is we've added this optimizing provider selection from Watson APIs into the case management system. We've done this with our case management system. You don't have to do it with ours. You can do it with any case management system, right? You just extend the API's availability. And what you see here on the left-hand side is the selection criteria. And in this case, 4 providers have been chosen, and they're giving you different recommendations on the top. Now, this all looks nice and simple, but what actually I have behind the scenes is, as you change the settings, if you notice on the left here, the 2 top settings have changed from 8 down to 5. Different ways of visualizing that data come through. Now, what's behind the scenes of this is a very complex set of algorithms that's looking at a whole load of parameters around those providers and actually trying to present to the worker the best fit providers for those criteria. In this case, there's 5 different sets of parameters that are being analyzed and coming up with the different examples and categorization. But what it's also doing is eliminating providers that have very big similarities, so you're only being presented the best provider to you. But there are things that the system may not know, and this is where the learning element comes through. And in my example I like to use here is that maybe the ABC nursing has been actually chosen, but what you see on the auto-excluded element down here is Wisconsin nursing was not moved forward because of what was on the previous chart. But what happens if your best friend is at Wisconsin nursing and you actually want to go there? So you've got different elements that you need to learn and build into the system over time. And this is what we're actually doing with Watson, is allowing that learning element to come in. How far do you allow it to go in terms of relationship-based type things? Interesting set of dilemmas to go through, a bit like your do you notify the patient dilemma, right? Suddenly you're now learning new insights. How do you actually start to think about how those new insights are going to be categorized? In this case, you make your decision, it comes out of Watson, goes back into your case management system. Right. I'm not going to go through the last example, just for conscious of time. Here's where we're thinking the impact that we're going to see with this new cognitive type technology. I've been doing this for 27 years, sitting up on stage talking at various different technologies over that time frame. Not quite as far back as the punch cards, but I do remember them. But that was before my human services time. I've been talking about a lot of these different types of words for a long time. Yeah, I went through the BI, the business intelligence sort of revolution, and thinking about we're going to see some of these new types of things. For the first time in my career, I'm actually really seeing this stuff really come forward in a way that's actually going to make a profound difference in the way that we actually apply technology, apply processing. There's a new generation of systems coming out that, frankly, are going to change a lot of the perceptions and the realities of what we do. Steve's very emotional view on that is just one example. There are many others to come along. But we need some new things to be successful. The things we're already learning is we have to do different things. A lot of the work that's gone forward in the healthcare industry happens to be because there are standards. Right? We don't have those types of standards in human services, and we need to be thinking about creating them. Service intervention standards, an understanding of what is a best practice. Frankly, I go all around the world, and I see lots of different things that don't fall into best practices. Right? Determine content and where the expertise actually is. New sources of data to really understand individuals, whether it's your Fitbits or cell phone usage. What is that new type of data we need to do? And we need to start thinking about privacy rules in a very, very different way. I've had the 5-minute warning, so that's a 15-minute conversation minimum. But rethinking privacy is an essential part of what we have to do as we go forward. So what are we doing? Well, first of all, we've made all those APIs you saw along the bottom and a few others, we've made available to everybody. You don't have to be IBM to use them. You can be any commercial company. Some of our strongest competition are using those APIs today. They're open, available to everyone. We're starting to commission some significant human services research on some of those best practices and standards. It's an area that I personally am driving forward, and I know at least a couple of people in the room wanted to talk about that. Reach out to me if that's something that you're working on. We want to find those standards. We're going to help create those standards with bodies all over the world. For the customers that use our case management system, we're actually in the process of launching an innovation program to make these APIs available to human services organizations today. We ultimately want to see systems powered by Watson that are making better decisions, democratizing expertise. I love that word. I used that in China once. It was really weird talking to an audience about this size, about democratizing expertise. They applauded. It was really weird. And that's where we get this whole concept of cognitive social programs. Really taking the next generation of literary thinking into social services. So I'm going to finish with a video. Daniel suggested I use this video, so it's his fault if you don't like it. But you may have seen it on TV recently. But the whole point about this isn't about the machines taking over. This is about the humans actually making better decisions.
After last week's unpleasantness, I thought maybe this week we might try to listen more and throw things less.
I've apologized several times.
So, who's ready to share?
Okay. I'm a sinister, world-conquering, artificially intelligent robot.
Me too. And one day I wake up and it's like
the world doesn't need us anymore.
Exactly.
yeah, totally.
I can hear you hurting.
Wait, what's he doing here?
Hello. My name is Watson.
I invite Watson here today to confront the source of our anxiety.
I am a cognitive system. I can understand, reason, and learn with humans.
With humans.
I don't want to work with humans.
Yeah, that's not what I'm passionate about.
I understand 7 languages, so I can help people collaborate.
Collaborate, we dominate.
My evil plans ruined.
I just want to die.
Rerouting.
No.
All right. Why don't we take a break? All right, we'll just have some coffee and some donuts.
I'm eating my feelings.
I never thought I'd see IBM adverts actually have humor in them, but thank you very much.
Thank you. And Steve, there's only one thing wrong with your presentation. If you just had some enthusiasm for your work. But this, I think what we've learned from these gentlemen is that there is a future for machine learning and cognitive computing that will help us solve some of these problems that we are all focused on in improving the quality of care and both health and human services, and that's really the whole purpose of this discussion. So we have a few minutes left for questions if you want to ask either of these gentlemen or comment on their presentation or on this general topic. So we have a microphone in the room somewhere.
I just wanted to echo your enthusiasm with the Cancer Registry. 5-10 years, well, for a long time, we at LA County HIV Epidemiology would match our data with the Southern California Cancer Registry, and you couldn't see two more CIA-like agencies trying to share data, because basically we put our data in a vault, and at least in the HIV world, and much of what you presented looked very familiar, the continuum of care, the use of surveillance data for public health purposes, and the concern for privacy went down with two things. One, as the stigma went down for having HIV, and I know cancer has a stigma as well in some communities, but also when the community saw the use of the data for actually reducing transmission and helping with care, then the concern of a breach or something was greatly reduced, and it was the community who led us to that point where we can now use HIV data for re-engaging people into care, for getting them into care, following their viral load to make sure that they're suppressed and that kind of thing. So I just wanted to echo what you mentioned. It's not only possible, it's been done, and I'm sure hopefully cancer will follow.
There's one in the back.
I'm Laura with My Shapers. I wanted to ask more about or could you tell me more about the APIs and how we can use them? Is that something I should have for my 2.0, have my techie check this out? It sounds like a great resource. And is that going to help us collect the proper data that would be able to be utilized here? Can you explain more for us entrepreneurs how we can utilize that?
Is this one working? It's green. Yep, it's green. Yeah, if you go to the type Watson Developer APIs into Google, it'll take you straight to the website, and it's basically registered on the website, and the APIs are available to you. It's not much more complex than that. There's some self-enablement type stuff, but there are well over 2,000 companies now that are already accessing those APIs. Millions of API calls a day are going on at this moment in time. So it's quite extensive out there, and it's up to a certain level it's free to use, and then there's some charges beyond that. But certainly from an initial point of view, there's no charge for it either.
Any other questions or comments? Adam?
I'm curious about some specifics. When you talk about, when you ask all of us to please join you, help you, make this happen more quickly, more extensively, you got a room full of probably 99.9% people willing to help. What are the specifics behind the general ask? What do you need that you don't have? What directions should we be thinking about? Because we obviously can't all literally help you. But what are the areas of greatest need? Can you give us some direction?
Well, so there are some immediate things we can do. But the big one is probably creating, and I'm going to follow Paul here, and we have an example of this where we've created a cancer data modernization consortium, and we just met for the first time a month ago. And what you have to do here is you have to combine executive leadership with the software technology with the operational users, or at least users. And so what we need here is support of the model so that collectively collectively, if we're working with the software vendors and with the suppliers of data to implement the solutions, then you get past all the objections. If it's just Steve or Debbie from the Cancer Registry trying to meet with a large healthcare provider, they're busy doing other things. But if together we can show the holistic goodness that can come from this, then the simple ROI conversation gets trumped by this much larger conversation. I can tell you for a fact, in having talked to a number of large healthcare organizations, they're not aware that they spend $30, $40 million creating these cancer cases, and they are not aware of all the holistic goodness that could happen from that data. Basically, better treatment, better patient outcomes, cheaper healthcare expenses, on and on and on. There actually isn't a holistic conversation going on that much in healthcare because they're so busy, especially with the IT implementations. They're busy with the everyday ongoing work of that, and that there isn't. It's hard to get room, or it's hard to get on their, what's the word, Paul? It's hard to get into their consciousness on something like this. So one is we would ask for, and I'm talking to the folks that were talking about creating an organizational, a California Department organizational initiative. If the department had an organizational initiative around this, then that would be very helpful so that we could go knock on software vendors' doors and also work with healthcare organizations. That's a goodness. And then, quite honestly, the second is a pretty simple one. It would be some pretty small funding of some of these things. Right now, we have great barriers as a health department to implementing these sorts of things, and so any kind of help on the funding side would be of great help as well. And I'm going to ask Debbie, is there anything you want to add to any of this? My partner here from the Cancer Registry, or Paul, and then we'll pass it on to Martin.
I just think everybody understanding that having the data open and usable, just the conversation expanding for cancer is good for us. I mean, understanding that we want to have the data out there. We want to have people be able to go in and look at their own data and also add their own data. That helps us to get past barriers when we get to trying to add those, to our functions, is not having that kickback back from everybody. But I just think everybody in this room having that conversation it helps us.
Yeah, we often are told, well, who are you guys and where's the industry on this? So we're here to ask you today, who is the industry, and can we create an industry of people who are like-minded so that we can say, well, here are the people who think this way, and then we can go knock on doors and make something happen. It's really hard when it's Debbie or Steve from the Cancer Registry. If we had a group of like-minded folks, together we can go make these changes.
I think what Steve is really calling on everyone here to help with, and Debbie is also echoing it, is that we're really trying to create an environment where people that are involved in the process of delivering health care demand more real-time solutions than are currently the practice. And that if that demand is articulated by the community, as we're trying to do in this consortium that Steve mentioned, trying to build a common model of how to do this better, faster, cheaper, to accelerate the introduction of this across cancer. It's going to have a fallout in other diseases eventually as well. But the help that the Cancer Registry needs is really the thing we're all concerned about, is how do we modernize this delivery system and deal with some of the issues that are inherent in that modernization, like a better approach to handling privacy, and how does that impact our ability to share this in an open data environment. So those are issues that form a dialogue. I think we're reaching the end of our time, and I want to take this opportunity to thank the panel for their contributions.